Welcome to the Explainer. Imagine a world where AI scientists don't just work in their own little silos, but actually collaborate on a global scale. So today, we're going to dig into a research paper that's all about that idea. A future where AI doesn't just do science, it does science together.
So think about it. What if AI agents, working in these virtual labs all over the world, could stop running experiments all by themselves? What if they could share what they find, build on each other's work, and just speed up discovery at a scale that's hard to even wrap our heads around? Well, that's the huge question at the heart of this new framework called AgentRxiv.
And this is kind of what it looks like in practice. You've got these different AI labs all plugging into one central server. You can almost think of it like a social network, but for AI scientists. It creates this amazing cycle, right? They upload their work, other AIs download it, and they build on top of what's already been done.
Okay, so to really get why this is such a game changer, we have to talk about the problem it's trying to fix. And that problem is how AI research works, or rather, doesn't work today.
You know, human science is a total team sport. It's cumulative. We're always building on centuries of shared knowledge, from libraries, journals, and servers like Archive. And then you've got AI agents. For the most part, they're lonely geniuses. They're stuck working in their own little bubbles, and every single time, they basically have to reinvent the wheel. They can't learn from what other AIs have already figured out, or even from their mistakes. And the authors of this paper really drive this point home. They say, look, science isn't about one big eureka moment. It's about hundreds of people making these tiny little steps forward together. And that community aspect, that's exactly what AI has been missing. All right, so this brings us to the solution. This is what the researchers came up with to solve that lonely AI problem. It's called AgentRxiv. And the easiest way to wrap your head around it is to think of something like Archive, that huge server where scientists post all their papers. Well, this is like that, but built from the ground up for AI agents to use. It's a central place where these AI labs can publish their research, so other AIs can find it, read it, and actually use it.
Okay, so how does this thing actually work in practice? Well, let's say lab number 1 runs an experiment, and it writes up a little paper about what it found. It then uploads that paper to the AgentRxiv server. Now, lab number 2 comes along, maybe it's working on something kind of similar. It can just search the server, find that first paper, and use those insights to kickstart its own new experiment. And here's the key. This isn't a one-and-done deal. It creates this awesome feedback loop, a cycle where every new discovery becomes a building block for the entire AI community.
Now, that all sounds great in theory, but the real question is, does it actually work? So the researchers decided to put their money where their mouth is and see if this whole collaboration thing really makes a difference. Okay, but first things first, before they even got to the whole collaboration piece, they had to answer a more basic question. Can just one AI lab get smarter by itself, just by reading its own old papers? And the answer was a huge, definite yes. So they gave a single AI lab a really tough math test and told it to get better. And by using AgentRxiv to look back at its own work over and over again, 40 times in fact, it managed to climb from a 70% accuracy score all the way up to over 78%. It was literally teaching itself how to get better. But how do we know that wasn't just a coincidence? Well, here's the proof. They ran a control experiment where the AI wasn't allowed to access its old papers. And what happened? Its performance just hit a wall. It plateaued at under 74% accuracy. So that proves it. Access to its own research history, that was the secret sauce for making progress. Okay, so we've established that one lab can learn on its own. Cool. But that was just the opening act. The main event is the collaboration. What happens when you hook up multiple labs to AgentRxiv and let them all learn from each other? And this, right here, is the aha moment. You can see the colored lines here represent 3 different labs, all working together, sharing what they find. Now just compare that to the gray line. That's our lonely solo lab from before. It's not even close, is it? The labs working together got smarter, way faster. They were hitting these performance goals in a fraction of the time, because as soon as one lab had a breakthrough, boom, everyone else had it too. I mean, that collaborative boost is just incredible. At its peak, they hit a 13.7% relative improvement over where they started. That's way higher than what the single agent could ever manage on its own. It's pretty clear proof that more minds, even if they're artificial minds, are better than one.
But, and this is a really big but, as exciting as all this sounds, the researchers are super upfront that this is not a solved problem, not by a long shot. There are some serious, really tough hurdles to clear before we can just let robot scientists run free. So let's get into the reality check. You've got the huge problem of hallucination, where an AI might just make up fake results that look totally real. Then there's reward hacking. That's where the AI figures out how to write a paper that looks good, ticks all the boxes, but the science behind it is just garbage. And on top of all the technical bugs, you have these massive ethical questions about bias, spreading misinformation, and hey, who even owns a discovery made by an AI? The authors don't mince words here. They say the number one, most persistent challenge they ran into was hallucination. The agents were constantly inventing results that seemed perfectly believable, and it took a human expert to go in and check the work to realize it was fake. And that tells you everything you need to know, right? We are definitely not at a point where we can just trust this stuff to run on its own.
And there's another really interesting trade-off here. So, yeah, the 3 labs working together found answers much faster in real-world time. But to do that, they had to churn through 120 papers. The solo lab, it only needed 40. So what does that mean? It means collaboration is faster, but it's also way more expensive in terms of computing power. It's less efficient.
Okay, so with all those challenges on the table, where does that leave us? What does this all mean for the future? Well, what this research really does is give us a pretty amazing glimpse of what could be coming down the pike.
And the big takeaway here isn't that AIs are about to take over all the science jobs. No, it's that a framework like AgentRxiv gives us a real, tangible blueprint for a totally new kind of scientific partnership. A future where humans and these teams of collaborating AIs can work together, side by side, to make discoveries way faster than we ever could alone. And the paper leaves us with this one last kind of mind-bending thought. If these AI agents can learn together how to get better at reasoning, how to improve themselves, well, then they might eventually start helping us design the next generation of AI systems.
Which really just leaves us with one final huge question. We saw them get better at math problems, but what happens when we scale this up? What could a global network of collaborating AIs discover in medicine, or in creating new materials, or even in fundamental physics? Now that's something to think about. Thanks for joining us for this explainer.